Today's lesson is on drawing ray diagrams for diverging lenses. So let's begin by looking at how we draw the rays for a diverging lens. So any ray that comes in parallel to the diverging lens does not get refracted downward because of its shape. It gets refracted upward, but not just any way upward. It gets refracted such that it appears to come from the principal focus, capital F, on the same side of the lens as the object. Our second ray is one that is opposite to that. If a ray comes in that it was going in the direction towards F on the opposite side, when it reaches the lens, then it goes parallel to the principal axis. And the third one, the easiest ray to draw, no matter if it's converging or diverging lens, is the ray that goes right through the optical center. It is a straight line because it is undeviated. So let's get to an example. A flower is placed 7.5 centimeters from a diverging lens of focal length 10 centimeters. Find by scale drawing the position, size, and nature of the image. So here, easy to draw the parallel ray to the principal axis, and when it reaches the lens, then it is going upwards like that, away from the lens, away from the principal axis, but such that it appears to come from F. So from F up to here is one straight line. Between F and the lens, we use a dotted line because this is a virtual ray. The ray does not actually come from here. Our second ray that we draw, easiest one to draw, as always, is the ray that goes through the optical center, just a straight line. Now, when I draw these two rays, I notice that the actual rays that are drawn with solid line, the real rays, they do not actually meet. They move away from each other. They are diverging. Since they don't actually meet up, then I do not have a real image. I have a virtual image. So here, where this real ray that goes through the optical center and this other ray that is the virtual ray meet, that is where the virtual image is located. So when I look at this image and I try to answer my 4 questions, is it real or virtual? First off, it is a virtual image because the rays do not actually meet each other, the real rays of light. Is it inverted in any way, or is it upright? Well, when I look at my object and I look at my image, I see my object is pointing upwards and my image is also pointing upwards. Therefore, it is an upright image. Is it diminished, the same size, or magnified? When I look at my object and I compare it with my image, I see that the image is smaller, so it is diminished. And finally, the location. Where is my image located? Well, my image is not on the opposite side of the lens, it is actually on the same side of the lens. And if I were to measure it, I would get a distance of 4.29 centimeters. However, that should be a negative number because it is on the same side of the lens as the object. If it is on the same side of the lens as the object, that means then it is a virtual image, and virtual images, their distances are negative.